So Windows CE supports two distinct application development models. The first being native code development. This would be a Win32, C, or C++ application. This could be MFC, the Microsoft Foundation classes, or ATL, the Active Template Library. The way that you write native applications is through embedded Visual C, and these applications target the specific processor that your Windows CE device is going to be running. So for example, if I have an x86 device and an ARM-based device, I need to build a binary for my application DLL or COM object for both devices that I'm running on. So I need an x86 and I need an ARM version of those binaries. Native code is always built for the specific target, the specific processor that you're running on your target device. In today's session, we're going to be looking at building managed code applications for Windows CE. In this case, we're going to be using C# as the language for our application. And this is going to be a fairly simple scribble application, an application that supports the ability for us to scribble in the client area of the application and capture that ink and display it back to the user. Okay, let's get started. This is VisualStudio.NET 2003, and this is the tool that I'm going to be using to write our application, our Scribble client application. I select File, New, Project, and this brings up the New Project dialog. I've already chosen C# as the default project type, but instead of choosing a Windows application, I'm going to choose a Smart Device application. And a Smart Device application is an application that targets Windows CE-based devices. What I'm going to do now is give our name, our target a specific name, and this is going to be Scribble Client. And this is going to be created in the folder Demo CFCE Lab. I click on OK. And now I get an option for the type of device that I want to target. I could target Windows CE, and I can either build an application, a class library, a console application, or an empty project. In our case, we want to build a Windows application. And we're targeting a Windows CE device rather than a Pocket PC or a smartphone. Now, the reasons why we have Pocket PC and smartphone in this list is because they have very distinct UI compared to Windows CE. Let me give an example. So smartphone has got an exact screen size. Pocket PC, menus are displayed at the bottom of the screen rather than at the top of the screen, and again has a very distinct, a very set screen size. For Windows CE, obviously the Windows CE device is pretty generic. Menus are typically at the top of the screen, and the screen size is determined by the OEM that's building the system. So obviously the form needs to be scalable to fit in with the screen size that we're going to be using. So I choose Windows CE and Windows Application, and then click on OK. So here is my basic form. You can see currently the form is slightly larger than the screen, but that's okay. We can scroll this around if we need to. On the left-hand side of the screen, I have my toolbox, and the toolbox gives me the ability to add a number of controls onto my form. Let's go ahead and add a menu onto our form. Here's the menu. You can see this is called Main Menu 1, and to change the contents of the menu, I simply click into the menu and type. So I can type File, Exit, and call Win32 API. That's it. Our menu is done. All we need to do now is write some code to sit behind the menu. Let me double click on Exit. Actually, single click first. And what I'll do is change the name of this from Menu Item 2 to be File Exit. I then double click on Exit, and you can see that I now have a File Exit click handler. And what I'm going to do here is just type this.cl. Here's IntelliSense coming in. It's already prompting me to say that close is perhaps the right option for me to use here. And in fact it is. So I can just type this.close. And when I select the File Exit menu option, what's going to happen now is it will give me the ability to shut down the application. I'm going to hit Control-Shift-B for build. This is going to build the application. In fact, let me just increase the size of my build window here. And you can see the application build was successful with no errors or warnings. Now I'm just going to hit Control F5, and this is going to launch the application. In this case, we're using the Windows CE emulation environment to host our application. We could just as easily use a reference board or a Pocket PC or smartphone to target our application. In this case, we're just using the emulation environment. One of the first things you'll notice is that the .NET Compact framework is not installed inside of the emulation environment. So what we have to do is download the cab files needed for the .NET Compact framework and expand those inside of the emulation environment to install the .NET Compact framework onto the emulation environment. Once these are downloaded and installed, we can then, of course, go ahead and run our application. We only need to do this once. We don't need to download the .NET Compact framework every time we run our application. And in fact, if we were targeting a reference board that already had the .NET Compact framework installed on it, then this step would be skipped altogether. We don't need to run through this process if our device already has the Compact framework on board. Okay, so at this point, the Compact framework should be pretty much down, and we should launch our application. So here it is. This is a pretty simple application. You can see the client area doesn't support any kind of scribble or mouse move support. But I do have my menu, so I can select File and Exit, and this shuts down the application. So the behavior is as expected for the application as far as it stands. So we're able to build our application, and we're also able to launch and close down our application. The core of our application is now in place. Okay, so now what I'd like to do is move on to the next step. And the next step is to generate a class library to host the drawing code for this application. What I'm going to do is select File, New, Project. Again, we're going to choose a C# project. This is again going to be a smart device application, but this time we're going to call this Scribble Control. I'm going to click on OK. And this time, instead of choosing the Windows application, what I'm going to do is choose Class Library and click on OK. So now we have a new class library. This has a class1.cs, a C# file, and you can see the code for this listed out on the screen here. Thankfully, all the code needed for this control is pre-written for me. So what I want to do is just delete class1.ces. This will be deleted permanently, that's fine. You see that the C# code window is now closed down. Now what I want to do is add an existing item. So I right-click, add an existing item, and this will be the source code for our Scribble control. I'm going to step up one level, and here is our custom control.cs. This is the source file that we're going to include for this application. If I open this out, we can examine the source code for our Scribble control. You can see that this already has a number of using statements, using system.drawing. Here's the namespace Scribble, and the class Scribble control derived from control. And we can step down this and we can have a look to see what's going on here. On mouse down, we can say that we're in draw, where we create an array list, we set our point that we're currently at, and then we add, on mouse move, additional points into that list. And on Paint, we draw the list of points that we have available. So the Scribble control is pretty straightforward. Okay, let's extend this. So one of the issues that we have with building controls typically inside of Embedded Visual C, or in fact inside of Embedded Visual Basic, is that controls used to have to be ActiveX controls. Now, the issue with using ActiveX controls is that the control itself was dedicated to only run on the device. You didn't get a whole lot of UI feedback when you're using ActiveX controls inside of Embedded Visual Basic, or using ActiveX controls inside of Embedded Visual C. Of course, what we want to do here is build a control that works not only on our target device, which in this case is the emulator, but also build a control that works inside of the design environment inside of Visual Studio.NET 2003 to give us some kind of visual feedback about how the control will look and feel when we use it on our physical device. Okay, so what we're going to have to do here is add some additional code into our control to support that design time support that we want to have inside of Visual Studio. Right now we need to add some references to our controls. So I right-click, I select Add Reference, and right now there are a couple of references that are missing from our control, one of which is system.drawing. So let me just scroll down this list and select system.drawing. And the other one that I require is system.windows.forms. Without selecting these two items, our control simply wouldn't build. So I select those two items, I click on OK. So those two references have now been added into our list of references supported by this control. Now let's go ahead and modify the code. So right now, this is simply a runtime control. This is not a design time control. So what I need to do now is add in some code that makes this accessible as a design time control inside of Visual Studio. Thankfully, inside of Notepad, I've got the code that I need. So I'm just going to grab the code that I need, and I'm going to insert this just before the namespace scribble. One of the things you'll notice here that we have a #if statement. If netcf design time, then this code becomes applicable at that time. Obviously, at the moment, we're not in design time, so I could actually type whatever I need inside of the if statement and rebuild the control without getting any errors. Next, I have a second piece of code that I want to add, which defines a property that I'm exposing out of this control, and the property is color. So what I want to do is look for a particular piece of code inside of my control, which is the exposed public color line color, and just insert again, this is going to be an if statement. If netcf design time, show this property in the property grid for this control. So what we're actually exposing here is a property of color and a description for this color, which is the color used for ink. So when we actually put this control onto our form, what we should then find is that we've got this additional property exposed for us, the property of which is color, and we get a description, the color used for ink. And when we select this as an item, we should then be able to choose the color that we're interested in. Okay, so now in our class constructor, what I want to be able to do, which is here, is add in support for, if we're in design time, a scribble control to be drawn for us, to give us some kind of feel for how the scribble control will look if we add this into the control. Okay, so let me just move this line up to the top of our if statement. Okay, so at this point we're pretty much ready to build our control. Let me just build that. You can see the control builds without any warnings or errors. The issue that we have at the moment is that we actually need two versions of this control. One version of the control needs to be registered as a design time control for Visual Studio.net, and the other control needs to be simply the control that we put onto the form, which runs inside of our Windows CE environment. So somehow we need to build that design time control and get it copied to the appropriate place inside of Visual Studio. This is typically a command line process. So let me just minimize Visual Studio.net, and we're actually done with Notepad for now. So I can minimize that and the emulation environment. I've set up a shortcut to the command prompt needed for Visual Studio.net. So I'm just going to open this out, and I've got a batch file which is called builddesignTime.cmd, which will build exactly the same source files for us, but copy those into the correct place and also define the runtime version of that control, design time version of that control. So you can see what we're doing here. As part of the build process, we're defining netcf design time. So all of that code that existed inside of the #if statements is now appropriate to be built as part of the build process for this control. Okay, so this control has now been built. The next step that we need to go through is to basically add this control that we've created into the toolbox that we're using inside of Visual Studio. So let me bring up Visual Studio. And if we're looking at the form for our project, so we need to step back to our form-based application. So let's open up File, Recent Projects, and Scribble Client. Okay, here's the client. You can see that we're currently looking at form.ces, form1.ces. This is the C# code for our form. Let's just move this back to design, and as soon as we step onto design, we get our device controls. Well, of course, what we want to do here is add in the control that we've just generated, the design time control that we've just generated. So we can right-click on Device Controls, we can select Add Remove Items, and what we now need to do is browse to the appropriate place to locate the control that we've just created. I click on Browse, and what I now need to do is browse to the appropriate place. Again, inside of Notepad, I've got the address of the design time control that we've just added. And here it is, design.scribble.control.dll. So I'm going to select that and click Open. And you can see this is now being selected inside of our toolbox. So I can now click on OK. And if I scroll our toolbox down, you can see our scribble control now exists inside of that list. So I can grab that control and drag that onto my form. Of course, because this is a scribble control, we want this to fill as much of the form as possible. So I can just size this out to fit onto the form that I'm currently using. Okay. So one of the things you may have noticed about this control is that we're in design time. And since we're in design time, you can see that we've got a representation of a scribble being displayed on the form of our application. If I come over to the properties for our control and just scroll this down, you'll notice that I have a property called color, which exposes line color, and the definition for this being displayed is the color used for ink. Right, so this is the custom color property that we added onto our control. What we have the ability to do now, of course, is to change the color to fit in with whatever we want on our form. So what I'm going to do is just scroll this down, choose an appropriate color like dark blue perhaps, and maybe you can see the color of the preview has now changed to match that of the preview that we have in the bottom right hand corner. Okay, now what we need to do is, of course, add a reference to the control that we've just added. If we expose the references here, the reference to our control that we've just generated does not exist. So I'm going to right-click and add reference. Again, I'm going to browse, and again, back in Notepad, I have the location that we're building our control to, which is demo CEF lab, scribble control bin debug. Let's just go back to Visual Studio, place that location in, and here's our scribble control. I click on Open and OK. Okay, so now I added scribble control. What I can now do is build my application and run my application on top of the emulation environment for Windows CE. Okay, let's step back to the emulator. Here is our form, and when I click on the form surface, you can now see that I'm drawing using the blue ink that I selected for my scribble control. Now that's pretty cool. Not only have I created a new control, but I've also added that control onto my toolbox. This can now be made publicly available. I could give this out to other people, they can add this onto their toolbox and get exactly the same scribble experience as I'm getting inside of my application. Okay, well that's all very well and good, but there are certain things that you just simply can't do inside of native code, inside of managed code, inside of the .NET Compact framework. For example, the .NET Compact framework is about 1.5 meg in size compared to about the 40 megabytes in size of the .NET framework for the desktop. Windows CE exposes approximately 2,000 APIs. Not all of those APIs are supported directly by the .NET Compact framework, so we need some way of being able to call code that exists inside of the operating system, perhaps in a native DLL, from a .NET Compact framework application. Let's go ahead and see how we add support for calling native code from the .NET Compact framework. So I'm going to shut down my application, select File and Exit, and that application has now been shut down. I'm going to come back to Visual Studio.NET, and now I'm going to start adding support for functions to call Win32 API. You remember that we've already added the menu handler. I click on File and call Win32 API. I can just double click on that function to add the menu handler for the menu item called Win32 API. Now, of course, what I want to do is add in support for calling the Win32 API. In fact, what we're going to be doing here is making a call to determine the current memory load on the Windows CE operating system image. In Notepad, I have the code needed to do this. So I'm just going to grab that code and then paste this in and explain what we've got. Okay, so what I'm doing here is creating a new structure based on mem status called foo, and this is going to be a new mem status structure. I then call the Win32 API global memory status, passing in a reference to the structure foo. Once foo is filled in, I then build a string called str memory, which is going to be equal to quotes memory load plus foo.dw memory load, which is an integer, and then convert that to a string. So I end up with a single string called str memory, which will say memory load equals, followed by a number somewhere between 0 and 100 in a single string that I then show on a message box. Right, so that's it. Now, unfortunately, the structure mem status doesn't exist as part of the compact framework. And the definition for the function global memory status also does not exist as part of the .NET Compact framework. So what we now need to do is add in support for the global memory status function and the memory status structure. So what I'm going to do now is come back to my code. I'm going to add in support for calling that native Win32 API, and I can just paste this in here above my menu handler, and you can see what this is doing. This is doing a DLL import on core DLL.dll, and the function is defined as public, static, extern, void, global memory status. So the function itself doesn't have a return value, but it takes as a reference a memory status structure called foo. Of course, the other thing that we need here is a definition of that memory status structure. Again, let me go back to my text file. And here is that memory status structure. So let me paste that in. So here's my structure. And you can see the length of the structure defined as well as the memory load, right? So this is the value that we're going to get out as part of calling this, this function. Now, if I build this application, the build process is going to fail because it can't find the import for the function DLL import. What we need to do is add a new using statement onto our application. And this is going to be called using system.runtime.interrupt services, right? The interrupt services are there for us to interoperate with some kind of external API, something that's native to the operating system. So I can now build. The build goes through fine. And what I could do at this point is just run the application. But instead, what I'm going to do is just set a breakpoint on this line here, which is mem status foo equals new mem status. And instead of hitting Control 5 to just execute the application, what I'm going to do now is just press F5 on the keyboard, which is going to push that application down to our target device, which is the emulator, and then run that application. So now in run mode, the application is running. We can switch back to the emulation environment and see that the application is there. I can scribble, and that's fine. And I can select File and call Win32 API. Bang. At this point, we're at a breakpoint. You can see that I'm at a breakpoint because I've got the yellow insertion arrow here showing my current instruction, and the fact that we have break up on the caption bar at the top of the program. What I can do now is just single step through lines of code. And at that point, we show our message box that shows that the memory load is currently at 15%. So not a whole lot of memory is being used inside of the operating system right now. I click on OK, and then I come back to my application. And I can hit function key 5 to allow my application to continue running and allow me to continue scribbling inside of the client area. Well, that's all very well and good, and that's kind of pretty cool, allowing me to do that. I built an application, it supports Scribble, and this also runs inside of the emulation environment. But let's just kind of kick this up a notch and do one more kind of interesting thing. What I'm going to do is just shut down this application. I'm going to minimize the emulation environment and also minimize Visual Studio and the notepads and command window that I've been using. What I'm now going to do is browse to my demo folder, to CFCE Lab, to Scribble Client, and then step into the Scribble Client bin debug folder. Right, so this is my desktop that I'm looking at now. This has got nothing to do with Windows CE. What I can see on top of my Windows XP desktop is the Scribble Client application and also the Scribble control that we generated inside of Visual Studio.net. So, what do you think is going to happen when I double click on the Scribble Client executable? One question to ask yourself here is, what was our previous target? Our previous target was Windows CE. So we have been targeting and running our Scribble Client application on top of Windows CE as an operating system. If I now double click on this application, the application runs on top of Windows XP without any modifications to the source and without me needing to rebuild the application source into a new binary. You'll also notice that I can scribble on the client area of this application, and the scribble is working in exactly the same way and also has exactly the same dark blue line color that I was getting inside of my Windows CE application. So how can this be? How can I run exactly the same application on top of Windows CE and on top of Windows XP? Well, the answer to that question, of course, is that the applications that are built inside of Visual Studio.net using either C# or Visual Basic.net are generated as MSIL applications, Microsoft Intermediate Language. The application binaries that I build are not targeted to a specific processor or to a specific operating system. So the MSIL binary will work on any of the processors supported by Windows CE, x86, ARM, SH, and any processor supported by Windows CE. The other thing, of course, is that because the MSIL binary is not targeting a specific processor or operating system, the application will work in exactly the same way on top of Windows XP. This gives me upward compatibility of my application between Windows CE and Windows XP. Now, of course, the one thing that we haven't had a look at yet inside of this application is calling that native Win32 API. The API that we were calling was Global Memory Status. This is an API that is supported on top of Windows CE, but is not supported on top of Windows XP. So if I now select File and call Win32 API, we get the expected behavior. We get an unhandled exception because that API that we're trying to call simply does not exist on top of Windows XP. In fact, core DLL.dll is not a DLL that's part of Windows XP. This is purely part of Windows CE. We could put an exception handler around our call to p-invoke that API, in which case we could trap the fact that the DLL was not found and handle that in a graceful way, in which case this application would work on both Windows CE and XP embedded with all the menu items supported. So I'm just going to click on Quit there to close that application down. Okay, so there we have it. During this lab, we've done a number of things. We've created a Visual Studio.net 2003 C# application to target the Windows CE operating system. We also generated a custom control, a scribble control for our client application. We added support for not only form runtime controls, but also design time controls for that control. Added our control to our toolbox, added our control onto our form, and also set some properties for that control and ran our application. That was a pretty basic application, but in order to extend the application to support some of the native APIs within Windows CE, we also made use of p-invoke, the ability for us to call out to a native API. In this case, we're calling the API Global Memory Status to return the current memory load within the operating system. That's it. I hope you get something out of this video. I certainly enjoyed presenting it. Thanks very much for watching.